Right. I intend to pull apart all of these ones, even the ones that don't, even the ones that do work, just to see what's inside them. So, looking at these, they're rusty. I think they're really rusty. See if we can get this apart. Okay, so there's one of the switches. Well, it doesn't look too bad, I'll be honest with you. I was expecting it to be all rusted out on the inside, but actually it doesn't look too bad. Okay. In fact, it looks pristine, I would say. I wonder whether I would have been smarter to actually, first of all, clean the lens on this, just to make sure it's nothing simple. Maybe I'll do that. Okay. Just in case that, you know, there's something wrong with the laser and that sort of... No, see, it's not moving at all. But I think if I sort of pick it up. Now it says on the display. Alright, so it's definitely more than that. Alright, good to know. I think I might just try and remove the unit. If I can... Looks like this ribbon cable, you just need to pull it out. Famous last words. Yep, okay. This is going to be a problem here. So, how's that connected? It looks like that is actually fixed. So hopefully we can just remove the battery terminals. Now they've been glued in, have they? That away. Maybe I'll just pull this up a little bit and just see what it wants to do. It's friction fitted here. I'll just see what happens if I... Oh, okay, so the display, unlike the other one, the display is built onto the PCB, basically. So you can just remove the whole thing. So let's just turn that over. Okay. It's hard to say, there's gunk here. It's difficult to tell whether or not that's corrosion or not. Okay, and you can actually take the laser assembly, disconnect that. Hopefully. Nice. Oh, so much easier to work on these than those damn cassettes. Right, so now I can go and have a bit of a squiz underneath the microscope. And we can see what's going on here. Right, so we're on the bench now, and yeah, that looks a little nasty there. That definitely looks like water. Yeah, okay. So there's corrosion damage to the board. Let's take a bit of a look around. Is it because of caps? The caps don't seem to have leaked. Yeah, that doesn't look so great here, but I don't see any damage to the tracks or anything like that. So what I might do is just give the board a bit of a spray and a wipe down. But really I'm more interested to see whether or not any traces have been. So like there. Let me have a look. Oh man, I didn't want to do that. I just sprayed IPA down into the LCD screen. That's not a good thing to do. That's I really need to get myself a proper container. So what have we got there? Yeah, nothing. It all looks fine. Right, I'm back to looking at these capacitors. I think perhaps I'll remove this one here. This seems to be the epicenter of something going on. And yeah, I'll remove it from the circuit and just test it, just to satisfy myself that it's not that capacitor is not leaking. So I'll crank up the soldering iron. We'll see if we can get that off. Okay, so there it is. It was a bit hard to get out. Just this fiddly to try and do it on the microscope. I don't know. To me, it looks like that liquid is on top of it rather than it leaking out of it. But anyway, it's out now, so we can test it. It's supposed to be a 4.7 microfarad. So let's test that with it out of the circuit. See how it goes. Okay, so I've put it back together. I just thought I'd give it a quick try after replacing that capacitor back in. Not that I think the capacitor has anything to do with it, but I did remove a glob of solder from the trace. But I mean, it doesn't make sense that that was a problem either, because, you know, then it would always have been a problem. But you just don't know, do you? And also sometimes pulling things apart and putting them back together has a magical way of helping. So let's just put that back in, press play. Now it's doing the same thing. I can hear the motor whirring around or trying to work. And I think if I actually tilt it, do I get that to work? No, so it's saying disk at the moment. It's thinking. It's not even moving now, whereas at least before it was spinning. Okay. If I go skip, it starts to spin. I press play, what does it do? No, it's grinding to a stop. Whoops. Oh, now it sounds like it's spinning. It's trying to spin up desperately. It's like the motor just doesn't have enough juice in it. So I'm wondering whether or not something's wrong with the motor, or it's the power being supplied to the motor. Perhaps there's not enough power. Anyway, that's okay. We're no further along than we were, but we haven't gone backwards. So that's always a good thing. I think it might be time to look at the mechanical part of this and see whether or not perhaps the motor is seized up, or I don't know. So what do we got here? We've got two motors. this one is attached to a whole bunch of gears, and this one is the motor that spins. It's attached directly to the spindle. Doesn't seem to have any resistance. Let me just check it against a known working one. Just wondering whether these are the same unit. No, they're different. It's alright. So one of these moves the laser as you read the CD, and the other one spins the laser. I'll just start pulling things apart and see what happens. Appears to be a tiny screw under there. You have to get the head in the right position to get at. I'd find a smaller screwdriver. This little set of jeweler's screwdrivers. Okay, has that got it? Am I kidding myself? It felt like there was some Loctite. Oh, there it comes. Quickly get that to safety. Yeah, that's weird. It's like, so there's a hole. There's another hole. There's a hole. Feels like, so now the motor is loose. So that's what's holding the motor in. But the spindle is still attached to the shaft of the motor, so it can't come out, even if the screws let it. I don't even know how that one is. Oh, well, that one there has got two screws just right there on the outside, which is where you want them. So we might as well do that. Think about the spindle in a second. Got one of them. It's the second one. Now there's all these gears in there, so oh, there it is. It's only a small motor, isn't it? And this is the gear mechanism. So does that spin properly? Is everything engaging? Yeah, it seems to move smoothly. That cog just sits in there. It's a pity that the shaft is completely protected. Can't like I can't twist it around from this side. I could open the motor up, I guess. It wouldn't be easy. But there's really not much to it, is there? I mean, it's just 1, 2, 3 gears meshing with a whoops, gently, just meshing with that. guess there's a sensor at this end. Yeah, so there's a push button at this end, so it knows when the unit has gotten all the way to the center, and then it probably moves outwards, which is all very nice. But now I've gone and played with this spindle. Thing is, I don't think there's anything I can do. I can't really pull this apart. It wouldn't do much good if I could. Yeah, this does appear to don't tell me I've lost that screw already. Did I get that screw out? Oh yeah, I did. Yeah, so either the motor is faulty and it doesn't have enough juice left in it. I suppose they're probably the same motor, right? If I could get the spindle off, I could swap this one for that one. Is that right? Maybe the same thickness? I think that they are. Am I kidding myself? Is that a different motor? I think they're the same motor. Would make sense, right? You would use the same motor. Just to make it easier for yourself. But how do you get the spindle off? I might Google it. See if there's anything online. I've got it set up now so that I can test the motors. I've got my bench power supply set to 3 volts. I have no idea what the correct voltage is for this. So this is the motor for that drives the linear rail. So that moves the laser to and fro. So I'm just going to apply 3 volts and see what happens. Yeah, that seems to be spinning quite nicely. I'm just going to reverse the voltage. Yep. That seems fine, which is interesting. Okay, so now I'll check the motor on the spindle, which is the more obvious one to be faulty, since we can see that the CD doesn't spin at the correct speed. Okay, let's test the spindle now. Apply the 3 volts. Yeah, it seems to be going very fast actually. It does make a little bit of noise, which the other one didn't, but maybe that's just because of the spindle. Yeah, you hear that? As I move it, the spindle is rubbing against the plastic. I think that's probably just because it's loose. I've taken out the screws out of that. So they work. Both motors appear to work correctly, at least at 3 volts, which I can't imagine the system is providing more than 3 volts. Oh yeah, the motor is... I've taken the screws out of the motor, so it's just sitting there. So, yeah, that's interesting. The motors appear to be okay. I just wanted to draw your attention to the motor that drives the laser linear motion. You could see that it's got gears on the shaft here, the plastic that moves up and down the shaft, which is then driven by another cog, which is driven by another cog, which is driven by a cog which is attached to the motor. And I noticed that that cog actually isn't attached to the motor spindle, like it's free to come off. And I'm wondering whether or not that's not driving this mechanism correctly. Because normally the cog that's attached to the spindle of a motor is attached some way, whether it's glued or it's pushed on with friction, like the spindle is here. I believe that's just pushed on. Because otherwise, as the motor spins around, the cog isn't going to move. The only other way that I could see that it would work is if the cog is sitting against the base. See, there's the spindle actually has a base to it, and if the cog sits on that, and then you screw the motor down, the force of pushing the spindle against that might be enough to make this activate, because I imagine it's not using it doesn't require very much force in order to move this, but it does seem a little weird. Now, why would that affect the CD not spinning up to speed? The only thing I could think of is that perhaps the linear thing needs to move all the way back so that it knows where 0 is. So we'll put this motor back in and we'll power it up again and see if we can get this this mechanism to move. Okay, so I'll reattach the motors. Now I'm going to apply power to the linear rail motor and see if it moves the laser along the carriage there. Just going to quickly touch it. 1, 2, 3. Oh, there we go. See it move? Yeah, it moves quite nicely. Just put a bit of tape on there. You should be able to see it move. I'll reverse the polarity of the electricity. Alright, you ready? Here we go. 1, 2, 3. Oh, I mean, it doesn't have far to move, so it doesn't take very long. But here we go again. 1, 2, 3. Yeah. So that seems fine. So let's assume that the motors are okay. It could be that the spindle motor, this one here, the platter motor, I guess, is not getting enough electricity, and that's why it's not moving correctly. But I think what I'll do is I'll put the whole thing back together and just make sure that I haven't fixed it just by simply pulling it apart. I also want to put some more grease down in the gears and on this linear shaft here, just to make sure it's all lubricated correctly. And then we might just put it back together and see if that's made any difference. You never know. I've done a whole bunch of tests with this. One of those things is I've put the bench power supply onto this so that it's not running from battery power. You know, I've applied electricity directly to the motors to see if they function, and they do. That sort of led me down the path of thinking that this motor here that operates the platter wasn't faulty. So I've looked for other things. I can't find anything else. And it's led me back to this motor. So if I apply power directly to this motor, it spins without any problems. But if I put a CD on here and press play, I can hear the laser mechanism homing. I need to push down on this. I can hear the laser homing, and sometimes I can hear the motor sort of sound like it wants to start, and if I turn it up on an angle, sometimes it actually does start spinning. But then, of course, when I apply power directly to the motor, it spins without any problems whatsoever. Now, I went and had a look at another unit, the one that's, let me grab it, this one here. And what I noticed, it was doing the same thing in that as soon as you press play, it seems like the laser homes itself first, which is what it needs to do, and then the motor spins up very, very gently, just for a little bit, and then it says, okay, I'm ready to play your CD. So what I think happens is that the unit is trying to spin the motor at very low power, so it doesn't spin at its highest speed, and it probably does that to make sure that there's a readable CD in there before it tells you how many tracks there are and whatever, and you can press play. And I think that's what's failing, because this is a brushed DC motor. And I was wondering why this behavior sort of felt like I'd seen it before. And I don't know if you've ever had a tumble dryer for your clothes, or a washing machine or something like that. Over time, they develop a problem where they just stop spinning. And so, for instance, with a tumble dryer, it won't start, and then it might start sluggishly, but then after a while you'll come back and try and use it and it won't spin at all. But if you give it a push, all of a sudden it starts. And that's because the brushes in the DC motor have worn out. And that's what I think is what's happening here. I mean, when the motor does spin, it actually makes a little bit of a grinding sound, which obviously wouldn't be what it should be doing. It should be almost silent. And the fact that it spins when I apply my bench power supply, I'm essentially giving it, the full 3 volts from my bench power supply, which can give it as much current as it requires, I think is actually leading to me misdiagnosing this, because it's actually, the brushes are worn out, it's trying to start, but the amount of power that this is pushing into the motor isn't the full 3 volts, because it just wants it to spin up a little bit, enough to be able to identify if there's a CD in there. So in the end, it's just a faulty platter motor, and unfortunately I don't have anything to replace this with. I looked through the other CD players that I've got. For instance, I took this apart, and it has a very similar motor but not quite the same size. And you can't really remove the platter. You can go online and attempt to buy a motor with a platter already installed on it, which is great, but I mean, I have no idea whether I can do that, because I've looked at all 5 of these portable CD players, and they all have, apart from the Sonys, which are Sony, same brand, they all have a different one of these mechanisms, and the motors in there are similar but not quite the same. So I think that's it for this video. So I'm sorry about that. I wish that I could have gotten this working, but this is going to be kept as parts. And even though the other 3 CD players that I've got physically work, I'm still going to pull them apart and see what's inside, and I will be examining the motors and the mechanisms inside those CD players to see whether or not they would match this, because I would love to swap this out and actually get this to work. And if that's not possible, then I guess I can always go online and have a look and see if I can't get something from China or AliExpress, somewhere like that. Well, the problem I forgot about was that I can't replace the motor even if I could find another one, because with the platter being on it, it prevents you from being able to remove it. So I guess I've got nothing to lose by attempting to force the platter off. What happened there? Did that come off? Oh! Well, it wasn't that hard after all. So if you replace the motor, how would you know how far to put this on. I guess you would just push it on and hope for the best. Maybe it doesn't matter how, as long as it's not touching the plastic, the laser's fine to read it. Okay, well then maybe what I should do is what I originally said and swap these motors over and just see if we can't. I mean, not that I'm expecting this motor to work as the linear one, but at least we could see whether or not it spins up the CD player, because it's the linear rail is already, the laser's already at position 0. Yeah, okay. So we're going to swap over these motors. This is the suspected bad motor with the bad brushes, and this is, I think, a good motor. So that's running the linear rail. There we go. So we just need to remove the motors now. And they're a different size. So they are completely different motors. They have a different sized shaft. And they're a different thickness. So what shall we do? Is there any way we could fit the platter onto here? No. Well, maybe let's just wire them up and like lay them all out on the bench here and see if we can't trick the circuit into trying to spin this motor. I think that's what we'll do. So I've screwed the motor back into here. Now, being the wrong motor, it only has a tiny shaft on it, but I think I might get this to sit on there just enough to see if it spins. So, is that on? I think it is. So this way, hopefully it will detect that there's a CD in there. So I know in order to trick it into thinking that that the laser thing is working, I just need to push the laser back against the switch, because I think when you turn it on, it actually pushes it out a little bit and then brings it back if it happens to be sitting against it, like a CNC machine would do. But if I can get that to work, how am I going to do this if I put the CD on there? It's going to be a bit tricky, but I'll just, yeah. I need to think something. Something I can get under there to push it. Actually, there's a hole there. Can I get something through that? No. I just have to be careful, I think. Let's just try this. So I'll put the CD on. And I think that's pressing against the slide. Okay, this is all a bit dodgy, but hey. Okay, here we go. So apply power, and then I press play, and it's trying, and then I need to press down on here. Oh, what happened then? Oh, that was the motor. The motor started turning. I thought something was on fire. Okay, so it's power, simulate the closing of it. Now it's wanting the laser to be pushed up against it, which I have. Now it's saying D. Spin the motor. Spin it. Why are you not spinning? It's just saying D1 and the motor isn't spinning. It's disappointing. Now it's turned itself off. Okay. Why aren't you spinning? Is that too much for you? Why don't we just try and get it to spin? Did I get this wrong? No, there's nothing impeding the motor from spinning. So you can see the laser module is going up and down looking for a disc, I think. But without the disc there, it just says D1 anyway. So I don't think it's detecting that there is a disc. Let me try that again. Okay, now it's saying error because it wants... Before it seemed happy that it was zeroed. So it's saying D. It's thinking D, D. I think it actually seems happy if the limit switch is being pressed when it starts up. So now it's saying D1. This is where I would expect it to spin that motor. And you can see that if I press that, all of a sudden this motor here, the one that I thought was faulty, is spinning very nicely. But I cannot get this motor to spin. So, you know, maybe it's not the motor. Maybe we're back to it being something else. I guess the only thing I haven't pulled apart is the actual head of the laser unit, so I might as well do that now. Even if it's just to see what's inside it. The screwdriver's not going to cut it. Oh, there it is. So let me remove this. Yes. Yeah, okay. I don't think it's glued, but it is clipped. So, and there we go. So, what's inside? Yeah, it looks like the laser assembly unit is sort of like a motor on its own, like a solenoid. What are they called? You know, they can change the magnetic poles and move it very slightly. Not very far, but just enough, and probably quite accurately. And that's all that's needed to basically, I guess, keep track of the data, and then the linear action of the thing can slide it along, and then this can compensate as it's reading. So that's why that's all wobbly and it can move up and down. So I mean, I have to look that up. It's just a guess. But yeah, I don't think there's much to be gained from this. I think I'm about ready to give up. Well, that's it. It's disappointing I can't fix it, but I don't think there's much point going on with it at this stage. But it hasn't been a complete waste of time because I have understood a lot more about how these mechanisms work. So I know that they'll have a switch here that indicates when the lid is open on the CD player. That then sends the system into a mode where it will attempt to zero the laser, and there's a limit switch on here that tells it when it has reached 0, and then it will start to spin up the CD slowly, I believe, in order for the laser to identify that it has a proper CD in it. And that's something I'm going to take with me to the next players that I'm going to pull apart and have a look to see if their mechanisms are the same, whether they work the same way. And who knows, maybe I might have some ideas and come back and attempt another repair on it. Anyway, I hope you enjoyed that. If you've got any ideas on what might be wrong with this, if you disagree with me or you agree with me, please put a comment. And yeah, I'll see you again next time. Ciao.